In this video, we're going to show you some examples on how to simplify these problems using exponent rules. For our first example, I have m to the 6th power over m to the 4th power. Our quotient of powers rule says that if we have the same base and we're dividing, then we keep the base. So that means I keep the base, and what I do with the exponents is that I subtract them, and you get 6 minus 4. You can write m to the 6th minus 4th power, which is equal to m to the 2nd power. Another way of seeing this is expanding the numerator to m times m times m times m times m times m. We're multiplying m 6 times. And in the denominator, I have m times m times m times m 4 times. And we can cancel one m in the numerator with one m in the denominator. And we can keep doing this until we run out of m's to cancel out. So what's left? M times m is left in the numerator, which is m squared, which is exactly what we got using the rule. But this is a visual of what's really happening. Some students will ask, why is the answer in the numerator, not in the denominator? Here's the answer. Because after you cancel out all the m's that are left are in the numerator, because there are more m's in the numerator than in the denominator. Let's see example 2. I have p squared times p to the 3rd power. The product of powers rule says that if you have the same base and you're multiplying, then you can keep the base. So let's work in the numerator. I can keep the base and I can add the exponents. So I can say p to the 2nd plus 3rd power over p, and that will equal p to the 5th power over p. Now I'm not done though, because now I have a quotient of powers. Now we're dividing and I have the same base. The rule says keep the base, so I'm going to keep it, and subtract the exponents. So 5 minus 1, there's no exponent written here, but remember there's an invisible 1 there, and we use it when we need it, and we need it right now. So 5 minus 1 is 4, so this equals p to the 4th power. Another way of seeing this is what we did here. We can write p times p times p times p times p, 5 p's, over p. Now we're able to cancel one p from the numerator with one from the denominator. How many p's are left in the numerator? P to the 4th power, which is exactly the same thing we got when we used the rule. For number 3, 4x squared times x over 12x to the negative 5th power. In this case, I want you to work with the numbers first. And what I want you to do with these numbers is, I want you to simplify it. That means you reduce the fraction, which means you look for a common factor. So a common factor between 4 and 12 is 4. That means I can divide 4 into 4, and I'll get a 1. And I can also divide 12 into 4, and I'll get a 3. So far, this is looking like 1 over 3. And now I'm going to work with my variables. I'm going to start in the numerator. X squared times x. I have the same base. I'm multiplying. So the rule says you add the exponents. So let's do that. And you keep the base. So x to the 3rd power. Remember, there's an invisible 1 here. And x to the negative 5th power. At this point, you could do 2 different things. I'm going to show you both things you can do, and you can decide which way you want to attack this problem. The first thing I can do is, since I have a negative exponent, remember that the rule says that we never want exponents to be written as negative. So one way to change that is, if the base with the negative exponent is downstairs or in the denominator, An easy way to make it positive is bring it upstairs into the numerator and automatically it becomes positive. So let's do that. I have 1 over 3. I have x cubed. And now I'm going to bring that x to the negative 5th power upstairs. But when I do that move, I'm really doing it so that my exponent becomes positive. So I moved it upstairs. And now what I have is, in the numerator, x and x, I'm multiplying them. That means I can add the exponents. So this becomes x to the 8th power. And in the denominator, what's left is 3. So here's your answer. A lot of students ask, what happened to the 1? Well, 1 times x cubed is just x cubed, okay? So we multiplied it. The other thing that you can do to solve this problem, if you don't want to move that exponent up, that base, that power to the numerator, this is the other thing you can do. You can rewrite it. I'm going to rewrite it. And the quotient of powers says if the bases are the same, you can keep the base, so that's 1 over 3. You can keep the base, here's the base, and you can subtract exponents. So I can say 3 minus negative 5. So that becomes 3 minus negative 5. And remember that minus negative is plus. So you end up with 3 plus 5. So this becomes x to the 8th power over 3. You get the same exact answer, just different procedure. Okay? So you choose which of these procedures you like best. In the next video, I will discuss these other 3 problems that are right here. I encourage you to try these on your own and then watch the video to see if you got them correct. Remember, anything raised to the 0 power is equal to 1.